Vanakkam. Welcome to this course on classics in neuroscience. We have been looking at the structure of the DNA, how the discovery of the structure of the DNA helped in shaping science, biology in general, neuroscience in particular. So, in the last class we saw some ideas that set the basis for this discovery. We will continue that discussion. So, in this video we will look at the research environment post the Second World War and how that led to the 1950s becoming the golden era of biology, and the race to discover the structure of the DNA and the structure of the DNA itself discussed by Watson and Crick. It is useful to discuss some context of this research or this work. Why is the 1950s considered the golden era? Why did it become the golden era of science, particular biology? It turned out that the large scale scientific environment or the large scale scientific organization that was there in the West, in particular in the United States, was critical for the Allied forces to win the Second World War. At least that was the thought process. So, the Western nations, in particular the United States, was very keen on keeping this advantage to themselves. In other words, they wanted to continue to support large scale science because they thought that that would be a deterrent to any future aggression by any other country. So, this is the historical background. This is beyond the scope of the course. We are interested in classics in neuroscience and the history of neuroscience, but still it is not like neuroscience exists alone, because neuroscientists are also humans who have specific citizenship, who work in specific countries, and so they will need support from the governments or organizations, scientific organizations, to continue their research. So, in the 1950s, early 1950s or the late 1950s, the realization in the United States was that large scale scientific organization was critical in their success, and they wanted to make sure that they maintain this advantage over other nations. So, they came up with methods to keep this advantage themselves. One was the formation of the National Institutes of Health to improve human health in general, but a stated mandate of the National Institute of Health is to improve the health of American citizens. So, something to keep in mind. National Institutes of Health, although funds lot of studies to improve human health in general, but the stated goal is to improve the health of American citizens, because after all these are funded by American money. So, their goal is to improve the health of Americans. So, NIH came up with this method whereby funding is given directly to a principal investigator rather than to departments or heads of the departments, who then distribute it to senior people. So, when it was PI driven research, PI referring to principal investigator, anybody can compete. So, in a way this approach democratized funding of science in the United States in a very big way and increased healthy competition, or at least that is an argument that we can put forth. So, this provided an opportunity for younger colleagues to compete and work on bold problem statements. And also the fellowships that were given out by these funds came with few strings attached. Let us remember, this is 1950s. Compared to today's standards, the fellowship funds that was given out in the 1950s were rather modest, but that is not to say that the today's funding for PhD students is somehow adequate. It is still not adequate, but this fellowship funds with few strings attached gave an opportunity to PIs and their PhD students the freedom to pursue bold problems. because if there are strings attached that you will have to do this or you will have to deliver this, freedom is curtailed. The lesser the number of strings that are attached, the more the freedom, and that also means that the problems that are being worked on, the questions that are being asked are bolder, more important and more risky. It is this kind of science that is going to help push the boundaries, which is what we are interested in. So, the late 1940s and the early 1950s saw a sudden increase in funding for freely pursued research. What do you mean by freely? Free here refers to freedom, where questions that were being asked were more challenging, bold or risky problems, not the regular run of the mill problems. Why is this important? Because only these problems are more likely to lead to significant breakthroughs. Of course, these are problems that are going to be more risky to solve, or that also means that they are more prone to failure. This is always a continuum. So, there is a probability, there is a continuum of probabilities that exists, going from probability of success being close to 0 or being close to 1. But those that are having the highest risk are also the ones that are going to be the most rewarding. This is always the case. In this environment, in the early 1950s, James Watson and Francis Crick worked together to discover the structure of the DNA. Before we go to that topic, let us discuss about Watson and Crick themselves. James Watson was born in 1928. He was the so-called precocious child. Precocious child means someone who is the whiz kid, who is smarter beyond their age, so to speak. He actually participated in this, I think it was a radio competition called Whiz Kids. He was a whiz kid. Today this refers to those very young geniuses. So Watson was this precocious postdoc doing his postdoctoral training in the UK in his early 20s. Remember, he was a whiz kid, so he received his PhD quite early, and in his early 20s he was already a postdoc. Crick was born in 1919, and he was working as a postdoc in Cavendish Labs, working with Lawrence Bragg, and he was looking for some exciting problems to work on. So Watson and Crick, they met together and they decided that they are going to make this attempt to discover the structure of the DNA, because it was one of the hard problems that was being pursued at that time, and they believed that they had it in them to crack this problem. Remember, it is critical to work with people who you are extremely comfortable working with whom you have a working style that you complement each other, something of that sort. Crick and Watson were exactly that. So it was very important that these two personalities were able to work together with each other, right? Watson and Crick themselves did not collect data, did not do any experiments themselves. Rather, they obtained data, they collected data from people who performed research in similar topics from other labs around town. This is critical to remember. This is not their data. They took data from others. Crucially, they took data from Rosalind Franklin, who worked with Maurice Wilkins in London. Remember, Rosalind being a lady doing her own research on crystallographic structure of DNA, had substantial data on this topic that was not yet published. Also, she did not have a model to explain her data. So this data Watson and Crick obtained through some means. The exact nature of this is a matter of debate, but they got their hands onto this data and they prepared a model that could explain this data. Their model showed that the DNA consisted of two complementary intertwining helices of matching base pairs, a purine and a pyrimidine, which is the nucleic part, that are attached to the other outer sugars, which is the deoxyribose part, and a monophosphate. This is the model that they came up with. They reported their findings as a short communication or a short article in Nature in April 1953, almost 71 years to date. The title of that was Molecular Structure of Nucleic Acids, a Structure for Deoxyribonucleic Acid, DNA. This article or this issue of Nature also had an accompanying article by Franklin and Wilkins that reported on the crystallographic data, crystallographic part. Many works are famous for their first sentences, but this paper was famous for their last sentence. The last sentence was, "It has not escaped our notice that the specific pairing we have postulated immediately suggests a possible copying mechanism, critical copying mechanism for the genetic material." Because as we saw in the previous few videos, people were interested in identifying what is this hereditary material, how is this inheritance happening. So, this structure of the DNA suggests a possible copying mechanism is something that they postulated along with the structures. So, the structure will have to provide a means for this copying to happen, because it was long believed that any structure that you provide must account for this copying that is happening, or this heredity being passed. Somehow we must account for that. This was believed even before the structure was revealed. In other words, we already knew that DNA was perhaps the key to understanding this copying. So, any structure of the DNA must already show, or any model of the DNA must already account for this copying mechanism, which is why once they proposed this, they suggested that it has not escaped our notice that the specific pairing that we have postulated immediately suggests a possible copying mechanism for genetic material. And after this, they went to a pub, and along with their colleagues they celebrated, they raised a pint and said they discovered the secret to life. Only much later, remember, this is the good old days, it takes time for information to travel. Right? 6 weeks later, New York Times reported that 2 scientists in England had reported on the chemical nature of the gene. So, 1953 was a crucial spring. Everest, or Mount Everest, had already been scaled. Elizabeth was crowned, Stalin was dead. But the most crucial of them all was discovery of the secret of life. But this discovery barely made any ripples in the rest of the world until, for example, New York Times discovered it much later, a few weeks later. This race has been discussed in the works of, or the books written by Watson and Crick. Watson's The Double Helix, Crick's The Mad Pursuit, and other such books that refer to this story. It's an interesting story. I request you to pursue this reading on your own. Early reports of how the structure of the DNA was discovered perhaps changed the way in which science was performed, done after that, in a very big way. In particular, science now became an exhilarating race, more like competitive sport, between the gifted ones like Watson and their more ordinary peers, many others who also pursued this. Rather, what actually happens in labs are modest steps, really minuscule steps made on a daily basis to understanding some dimension of a larger truth. This is what is happening. Science is not a race, but the way in which the reports came out and the way in which this was being discussed, it almost appeared as if science was a competitive sport. Remember this. Also, this marked the shift of scientists being in formal clothing such as full sleeve shirts and ties to t-shirts and sneakers, suggesting some semblance of play or sport to what they do. Something to keep in mind. Today, PhD students usually come to their labs in sporty attire. The reason is what they do is some form of sport. I like this, but this shift came about only after this discovery of DNA. Once it was more like competitive sport, or it was at least viewed that way. It started being discussed this way. Importantly, we need to discuss the ethics behind using other people's data towards doing your own science. Remember, Watson and Crick did not collect any data. They got hints, clues and data from other colleagues who were working on this topic. They pieced together information from more than one source and made a beautiful model. We are not questioning the smartness of these colleagues. The question here is about the ethics of using some other people's data without properly crediting them. Right? But remember, this was the 1950s, so we need to keep that in mind. Also, Rosalind Franklin's data was made available to Crick and Watson without her knowledge. For her part, Rosalind Franklin actually acknowledged the beauty of this structure that they have proposed and suggested that it was indeed correct, the structure was indeed correct, and she went on to become friends with both Watson and Crick. But she passed away before the award of the Nobel Prize for this. But the question remains, would she have been awarded the Nobel Prize if she was alive? Because in the good old days, there was no posthumous award of the Nobel Prize in the good old days, or at least at that time. The question still remains, because she is a lady, would she have been awarded the Nobel Prize if she was alive? She was not considered for the prize because she was not alive at the time of the award, but would she have been awarded otherwise? That question continues to haunt women scientists, all of us. Some injustices in how we acknowledge or how we do not acknowledge the contribution of women scientists in the pursuit of mad science, or the mad pursuit, or rather the race that we are in. Something to keep in mind. If we look at what happened in the 1950s, we will cringe. For example, Rosalind Franklin was not allowed into the lunchroom at King's College where she worked in the 1950s. And today we look back and cringe, is this how people behaved in the 1950s? Here is a question. 50 years from today, would we look back our current behavior and cringe? I mean, have we really reached reasonable levels of behavior where we provide equal or reasonable opportunities to women and people who come from disadvantaged background? Have we done that? It is a question for you, there is no answer, it is a question. Also critically, the role of modeling was highlighted in a big way in this work. That is, data is important, but so is modeling. That there is this belief that experiments alone are sufficient to push the boundaries of science. The discovery of the DNA is a strong refutation. It is not just experiments, but a model to explain the data that come out of the experiments also plays a crucial role in pushing the boundaries of science. This led to an explosion of work in the field of molecular biology, where people were assembling physical models. For example, by the 1960s, there was a model of hemoglobin available, and people were modeling many other molecules. These became available, and later the use of computers in modeling led to this explosive growth in the field of molecular biology. And in the 1960s, when Crick was asked what is the future for modeling, he said it has served its main purpose, something to keep in mind. That was actually the beginning of this explosion. And when Crick was asked, what do you think is the role of teamwork? He famously said that success depends on not being courteous to each other in the lab. Is that something we would find acceptable in today's world? Question. I suppose what was meant was that, success depends on not being nice when it is not necessary to be nice. In other words, if the work is not done properly, it is crucial for colleagues and collaborators to provide this honest feedback and saying that this is not done well, we need to repeat this or we need to improve this. If you are putting personal relationships or if you are putting courtesy ahead of the correctness of the work, then what happens is the quality of the work is compromised, or at least this is how I would interpret this statement by Crick, where he said success depends on not being courteous to each other in the lab. What that means is that it is important to give honest feedback on the work without insulting the person, without hurting the person. With this, we come to the end of this video. In this video, we discussed how the new research environment of the post-World War 1950s led to this explosive growth in high quality science, and the race and the environment that prevailed in the 1940s, the late 1940s and the early 1950s, that led to the discovery of the DNA, and some details about how the structure of the DNA was discovered, and questions about whether it is reasonable to use somebody else's data without them knowing. Thank you very much for your attention.